Hi guys, and welcome to lesson 2.11, the applications of polynomial equations. So we'll start with this first example here where we want to create an open top box. And so the way we create that is we have a rectangle here that is 50 centimeters by 30 centimeters. So from edge to edge we have 50 centimeters for the length, and edge to edge we have 30 centimeters for the width. Now we want to cut out 4 equal-sized squares of side length x, so that we can cut these squares out, and then what's going to happen is we're going to fold these edges here, and if we fold those edges up, what happens is we create this open topped box. So the question is saying, what size square should we cut out so that we can create a box with a volume of 4,000 centimeters cubed? So to start this question off, what we're going to do is give our little let statement here. We want to say that x represents the side of the square, so the side length of the square that gets cut out. And just with the last application problem that we did a few lessons ago, we'll start with what we know. We know that we want to create a volume of 4,000 centimeters cubed. And we also know that the volume of this box will be calculated by taking the length, multiplying it by the width, and then by the height. So let's fill that in. We know that we want to create a volume with 4,000 centimeters. Now before we go ahead and sub in length and width and height, we want to come up with some expressions for it. Notice that from edge to edge, we said that the length was 50. Now we want to cut out this length of x and another length of x. So the distance between those two purple lines is x. So a statement for our length would be 50 and then take away 2 of those x's. Same idea for the width. From edge to edge, the width is 30. But we want to subtract these little green squares that are length x. So our width would be 30 minus 2x. Now the height is created by whatever side length x is. So the height is just x. So what we're going to do is take all that information and sub it into our formula. So the length is 50 minus 2x, the width 30 minus 2x, and finally the height is just x. Now, just like with every other question we were trying to solve for the variable, you want to make sure that one side equals 0. So we're going to go ahead and move this. And what we'll need to do now is expand, and then later on try and refactor once we've collected all like terms. So what I'll do is expand the last 2 brackets, so I'll leave the 50 minus 2x alone, and I'm left with 30x minus 2x squared. And then we'll expand these 2 brackets and then minus 4,000. So it's really important at this point that we collect like terms and write our statement in descending order of exponents. So I'll start with the 4x cubed, and then I'm going to collect our x squareds. So we have negative 100x and minus 60x squareds, giving us negative 160x squared. We have 1500x and no other x's, so just 1500x. And then finally our constant minus 4,000. So now that we've got this, we want to try and factor. So remember factoring, the first thing you want to try and do is common factor. So actually I noticed that 4 is common to all terms, leaving us with x cubed minus 40x squared plus 375x, and then finally minus 1000. So what we can do now is just focus on the cubic that is inside this bracket here. Now take a look, see if you can try and do factor by grouping, which we can't. There's really no other method except to use factor theorem. So what we want to do now is sub in a test root just to the polynomial that's inside the bracket here. So I'll try subbing in a root of 5. And if you actually do that, you should end up with remainder 0. So that tells me that x minus 5 is going to be a factor. And because f at 5 gave us 0 when we subbed 5 into that polynomial, we can use synthetic division now to break it down even further. So I use the test root of 5, and our coefficients are 1, negative 40, 375, and minus 1,000. So we will drop down the first term and multiply the 5 and the 1, and then add these two terms together. And then we'll multiply, and then add them up, multiply by 5, and then add them up. So I do indeed get a remainder of 0. So our polynomial can be broken down into, well, we already stated that x minus 5 is a factor, and then we're left with x squared minus 35x, and then plus 200. So what we need to do now is factor the quadratic that's in the second bracket here. Unfortunately, we can't find two numbers that multiply to 200 and add to 35. So we have to use everyone's favorite quadratic formula. I can state that one of my roots is going to be 5, which we've stated earlier, and then our other roots are going to be calculated with quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c, so it should give us 800 there, and then all over 2 times a. Alright, so if we simplify that a little bit further, we get 35 plus or minus the square root of 425 all over 2. Now you want to try and simplify the square root of 425. So if we do a little bit of side work, 425 can actually be broken down into square root 25 and square root 7, which is really nice because we know what the square root of 25 is. So this simplifies to 35 plus or minus 5 root 7 all over 2. And now I look at the top and I see that there is a common factor of 5. So I will factor that out. I'll take out a 5, leaving me with 7 plus or minus root 7 all over 2. Now the 5 and the 2 aren't going to simplify, so this is where we'll stay. Now because, even though we are fully simplified here, because we're dealing with some sort of measurement, we're trying to find the length of x, I'm actually going to go one more step and state the decimals. So if we were to calculate this, so 5 times 7 plus root 7 all over 2, you should get 27.8. And if you calculated it again with the minus sign, you should get 7.2. So we do end up with a few possible values for x. It could be 5, it could be 27.8, or it could be 7.2. Now we need to take a step back and think, are all of these values valid? So let's go back up and take a look at what we wrote for our statements for all the dimensions. Let's go ahead and sub in all of these values and see if each one is valid. If we sub in a 5, well, 50 minus 2 times 5, so 50 minus 10, that makes sense for a length. How about 27.8? If we sub in 50 minus 2 times 27.8, we actually end up getting 50 minus 57.6, which means we're going to end up with a negative value for our length, which doesn't make sense. So 27.8 is an invalid answer. So make sure that you go ahead and triple check all of your answers, subbing in what you got and making sure that they all make sense. So just kind of very quickly, if you subbed in 7.2, so 50 minus 2 times 7.2 ends up being a valid answer in each one of these dimensions. So we have two possible answers. We have x equals 5 and x equals 7.2. Alright, so let's move on to the next example. In this example here, it says the value v in dollars per share of a new stock T weeks after the stocks is issued is given by this equation here. And according to the relation, when will the value of the stock be greater than or equal to the $12 per share? So greater than or equal to. That right away, that tells me that we're trying to solve for an inequality. So I'm going to take our function, t cubed minus t squared plus 20t, and I want to know when that is going to be greater than or equal to $12 per share. Okay, so this 12 is the value, that's v. Now in order to solve the inequality, just like factoring, you want to make sure that one side does equal 0. So we move the 12 over, and then we end up having a cubic here. So again, go through the motions. Is there a common factor? Can we do factor by grouping? In both of these cases, no, that's not going to help us. So again, we are going to use factor theorem. Now that we've got our function fully factored, what we can do is test some intervals. So we have roots at positive 1, positive 2, and at positive 6. So what we want to do is test values in between these roots. So less than 1, I'm going to try testing x equals 0. So when I sub in 0 into each one of these brackets, I get 0 minus 1, that's going to be a negative answer. I'm going to get 0 minus 6, which is also a negative answer, and then 0 minus 2, also a negative answer. And if you think about it, a negative times a negative times a negative, altogether is going to be one big negative answer. Now in between 1 and 2, we're going to try, let's say x equals 1.5. And if I subbed in 1.5 into this first bracket, I'd actually get a positive value. 1.5 minus 1 is positive 1/2. And then sub in 1.5 here, I'll get a negative answer. And subbing in 1.5 here, also a negative answer. Now positive times a negative gives us actually one big positive value. Now anywhere in between 2 and 6, as long as you pick a number in between that variable, you're good to go. So we'll try 3. Subbing in 3 into the first bracket gives me a positive answer, a negative in the second bracket, and a positive in the third. Altogether gives us negative. And then finally we'll try anything greater than 6. Subbing in 7 into each one of these brackets will give us all positive values. So 3 positives multiplied together gives us positive. So looking back at our statement above, we want to find when this cubic is greater than 0. So when we're taking a look at our sign line, we want to look for anything that is positive. So our answer So anything in between 1 and 2, and then again anything after 6. Okay, so what does that mean for us in terms of the question? Well, in between weeks 1 and 2, as well as in anything after week 6. Alright, so that is it for today's lesson, and as always, if you have any questions, please make sure you ask in class. Take care, guys.